Today's lesson is going to look at the percentage composition of compounds. How would you find the percentage of females in a class composed of 13 males and 17 females? Okay, well, to do that, we have to know the general concept of percentage. And a percentage is basically the part divided by the whole times 100. The part is the part that you're interested in finding. In this case, it would be the females in the class, and the whole is the group that includes the part, so that would be all of the people in the class or all of the students. So it would be number of females, number of students times 100. And looking at the equation, that's what we've got. Percentage females would be the number of females divided by number of students times 100. Part divided by whole times 100. So if we did that, we would have 17 females divided by a total of 30 students times 100. So 17/30ths and when we do the math, this is going to be equivalent to 56.7% of the class would be females. Okay, so part divided by whole times 100. Now, we can also look at percentage composition or percentages in terms of compounds. And the percentage composition of a compound is sometimes called percent by mass. This is the percentage by mass of each element in a compound. Or in other words, if we're looking at a compound, what percentage of the mass of the compound is made up by each element? This becomes important because of a fundamental law in chemistry that we mentioned earlier, discovered by Joseph Proust. And he found that the law of definite composition, which states that a chemical compound always contains the same elements in exactly the same proportions by mass, regardless of where the compound came from. So in other words, compounds have definite chemical formulas, and because definite chemical formulas have definite numbers of elements in them, such as H2O for water is a definite chemical formula for water. It's always 2 hydrogens to 1 oxygen. And because hydrogen has a certain mass and oxygen has a certain mass, then the percentage of hydrogen to the percentage of oxygen is always the same ratio, regardless. We always have the same amount of hydrogen per oxygen in water. If we change the formula, such as if we change to hydrogen peroxide, H2O2, our relationship, our percentage of hydrogen compared to percentage of oxygen will change. So percentage composition is a constant for a compound. Therefore, it makes it a very useful analytical value to look for, and it's one of the fundamental numbers that you would look for in the field of analytical chemistry, which is the field which analyzes substances for their chemical content. One of the first things that you'd actually want to do when you have an unknown compound is determine its composition, very often as a percentage composition. So let's look at how we would find the percentage composition of a compound and what that means in terms of a real compound instead of something like females versus students. So we want to find the percentage composition of copper 2 sulfide. From this viewpoint, when we're solving a problem of this type, we have to know the chemical formula. Copper 2 sulfide is going to be Cu positive 2, that's copper 1. So that would be Cu plus 1, and sulfide is the negative form of sulfur, which is a negative 2. So we have copper 1 sulfide. We're going to arrange it so that we have a net charge of 0, so that would be Cu2S. So you are expected at this point to be able to write chemical formulas. So in this compound, we have some mass due to 2 elements. We have some mass due to copper, and we have some mass due to sulfur. It doesn't matter what unit we use for this. We could use AMUs or grams because the ratio or percentage, which is a ratio, is going to be the same regardless of the mass system used. And I'm going to use grams as I do this, so when I go to the periodic table to look up masses, I'm going to do it in terms of grams. Now, if we have 1 mole of this compound, we'll put a 1 out there, that's 1 mole, then we have 2 moles copper and 1 mole sulfur in this compound. 2 moles to 1 mole. Okay? So what we have to do, if we want to know the percentage composition by mass, we have to convert our moles over to masses. So our first step, if we're given a chemical formula, is deciding how many moles of element we have for each element in the compound, and then convert those moles over to masses. So 1 mole for copper, 63.5 grams to 3 sig figs, and that's fine for these. And 1 mole of sulfur, 32.1 grams. That gives us 127 grams of copper and 32.1 grams of sulfur, with moles in each case canceling. Okay, so if we want to know the percentage of, let's go with copper first. Percentage copper is going to be equal to the mass of copper divided by the mass of Cu2S, part over whole, times 100. That's going to equal 127 grams divided by 127 grams plus 32.1 grams. That includes everything in the compound, times 100. And when we do the math, we come up with 79.8% copper. The percent sulfur carried out the same way. Percent sulfur is going to equal the mass of sulfur divided by the mass of Cu plus the mass of S, or mass of Cu2S, times 100. This is equal to 32.1 grams divided by 127 grams plus 32.1 times 100. We're running out of space there. That gives us a percentage sulfur, after we do the math, of 20.2. Of course, we only have 2 elements here, so 79.8% copper plus 20.2% sulfur gives us 100% of Cu2S. So we can always add up the percentages and check for the 100%. Okay, next problem. Next problem, we want to find the percentage composition of lead-2 chloride. Lead-2 chloride is going to be PbCl2. So this means that we have 1 mole Pb and 2 moles of Cl. So we want to convert those to masses. And that gives us, let's see, 1 mole lead is 207 grams. 1 mole of chlorine is 35.5 grams. So 207 for this one. And 2 times 35.5 is going to be 71.0 grams. We can total those up to get the mass of PbCl2, 278 grams. Would be our total. Okay, so if we want to know the percentage of Pb, then we're going to have 207 divided by the total, 278, times 100, and our percentage of chlorine, following the same pattern, is going to be our mass due to chlorine, 71 grams, divided by total, 278 grams times 100. Percentage-wise, for lead, that gives us 74.4%. It's a percent symbol. And then we have 25.5% for the chlorine. Let's look at one that's got a polyatomic ion. We want to find the percentage composition of barium nitrate. Barium nitrate, PaNO3 2. Okay, so this one's a little more complicated. We have barium, 1 mole of Ba. We have 2 nitrogens, 2 moles N, and we have 2 times 3 would be 6 moles of oxygen. We want to convert these formula amounts into masses. 1 mole of barium is 137 grams. 1 mole of nitrogen is 14 grams. And 1 mole oxygen is 16 grams. So this gives us 1 times 137 is 137 grams barium. 2 times 14, 28 grams nitrogen. And 6 times 16, 96 grams oxygen. That totals to 261 grams. So our percentage barium, A, is 137 grams divided by 261 grams times 100. Our percentage nitrogen is going to be 28 grams divided by 261 grams times 100. And our percentage oxygen is going to be equal to, let's say, 96 grams divided by 261 grams times 100. That gives us for barium 52.5%. For nitrogen, 10.7%. And for the oxygen down here, that would be 36.8%. Problem done. Okay, time to try a hydrate. And we want to know the percentage composition of water in zinc sulfate heptahydrate. So let's write an equation for what it is that we actually want. We want the percent of H2O. To do that, we need to know the mass due to H2O divided by the mass of ZnSO4.7H2O times 100. So what we have to find is the mass of the entire compound. So to do that, we have to add the total masses. And then we have to find the mass of water, which is 7 waters, and then plug in and solve. So let's start by finding the individual masses. We've got 1 mole of zinc. We've got 1 mole of sulfur. We've got 1 mole of oxygen. No, we don't. We have 4 moles of oxygen. And since I want to know water, I'm going to say I've got 7 moles of H2O, rather than breaking it apart into hydrogen and oxygen. The 7 is, of course, the coefficient. So I've got 1 mole of zinc. We need to convert to masses so we can add up the total mass. 1 mole of zinc is 65.4 grams. 1 mole of sulfur is 32.1 grams. And 1 mole of oxygen is 16 grams. And then we've got water, at H2O. That's each water. Hydrogen equals 1.01 grams times 2 equals 2.02 grams. Oxygen equals 16 grams. So 16 plus 2.02 is 18.02 grams, or I'm going to go with 18 grams. In every 1 mole. Alright, so we have, that gives us 65.4 grams of zinc, 32.1 grams of sulfur, 16 times 4 will be 64 grams of oxygen, and 18 times 7 will be 126 grams of water. Add this all together, you get 287.5 grams. So if we want to know the percentage of water, I'm going to follow this equation. We have the mass of water, which is 126, divided by the total, which is 287.5 grams, times 100. That gives a percentage of water equal to 43.8%. In this problem, we're going to look at maybe a use of percentage composition, one example at least. We'll have others as we go along. But in this problem, we have some magnesium hydroxide, which is MgOH2, and it's 54.87% oxygen by mass. We want to know if we can take the oxygen out of this compound, what mass of oxygen could we get if we have 175 grams of the magnesium hydroxide. So we have 175 grams of MgOH2. How much oxygen? Okay, well, we know it's 54.87% oxygen, so we can say 54.87% of 175 grams of MgOH2 is oxygen. So all we need to do is take 54.87% of 175. So to take 54.87%, theoretically what we would do is we would say that there are 54.87 grams of oxygen for every 100 grams of MgOH2. That's the part divided by whole. 54.87 divided by 100, then multiply that fraction by 100 would give you 54.87 again. So to say 54.87%, that means for every 100 units of the whole we have, 54.87 parts would be there. And technically speaking, a percentage is a parts per 100. So what happens here when we do this mathematically is we get 54.87 divided by 100, which is 0.5487. And this is just a number, 0.5487. 54.87, we move our decimal place back twice, and we get this. This is the number that we multiply. This is the fractional abundance, is one way to put it. We multiply this fraction by 175 grams. And that gives us 96.0 grams of oxygen. So anytime you have a number, a percentage, and you want to use that number to multiply by something else, divide by 100 first. So if we had something like 63% of 800, we would say 0.63 times 800. Okay, and I know that's something that you've learned before, but it's worth remembering as we are going to be using percentages quite a bit. That finishes the presentation on percent composition. Following this, we will be actually doing a couple of lab activities as well as some problem solving. Make sure you take notes and upload.